Hello. Hello. Aknawaz, can you hear me?
Yes, sir.
Right. Okay. We are going to start this class of advanced calculus. Okay. Welcome to the class of advanced calculus. This is the 8th lecture of the course. Last lecture of midterm. Today is Saturday, 2nd January 2021. Today, inshallah, we shall discuss total differential. In our previous lecture, we defined partial differentiation of higher order, and today we shall discuss this total differential.
स्लाइड नहीं है सर, स्लाइड स्क्रीन पे नहीं है।
साइड स्क्रीन पे नहीं है, यहाँ पे तो है। आप
स्क्रीन पे नहीं शो रहा सर।
स्क्रीन पे नहीं आ रहा है। चलो 1 मिनट वेट कर लें, मैं बुला लेता हूँ उनको।
ओके सर।
ये स्लाइड आ रहा है स्क्रीन पे?
नो सर।
अच्छा, ओके, जस्ट वेट ए मिनट प्लीज। ठीक,
ओके ओके सर।
स्क्रीन बंद स्लाइड नाराजी
सब्जेक्ट कमी होगी सर।
दगा कोर्स नहीं। Slides weet je nog carry.
अभी शो हो रहा है सर।
Also carry का ना?
यस सर।
यस सर, यस सर, यस सर,
Right.
यस सर।
Okay. Right. Let me repeat. We shall discuss a total differential. अब differential होता क्या है? If you are given a function, say f of x, in 2 variables or in 1 variable, say f of x, that is y is equal to f of x, then the differential of this y is by definition equal to derivative of the function with respect to x, and then write dx with this derivative of f of x. That is derivative, this differential of y, which is denoted by dy, is equal to f prime of x into dx First, try to find the derivative of the function with respect to the independent variable, and then simply write with the f prime of x or derivative of f with respect to x, उसके साथ dx लिख लें, then this is called derivative of y. As you see in this definition, if you are given function in two variable, first differentiate f with respect to x partially, write dx with the f prime of x or fx here in subscript, which notation you use, it's up to you, plus then differentiate the function partially with respect to y and write dx. Then add this differential, then the sum is called total differential. So by definition, the total differential of the function, for example, in two variable or more, is the sum of all its partial differentials. जितने भी partial differentials होंगे, अगर two variable है, you have two differentials. If your function is in three variable, you will have three differentials. Add them up, then this sum is called total differential. For instance, for example, consider the function w, which is equal to a function f in two variables x, y. The differential of w, which is denoted by dw, or differential of f, which is denoted by df, is then given by dw, which is equal to df, because w is equal to f. By definition, it is equal to, as I said, differentiate f with respect to x, write dx, plus differentiate f with respect to y and dy. Then this sum is called total differential. If your function is in three variables, add the other term, differentiate function f with respect to z into dz, and so on. This is the definition of total differential. Instead of writing dy or dx, we write simply dy equal to this derivative of the function into dx. This is the definition of differential. And if you have a function in two variable, differentiate with respect to x, y, if it is in three variable, also differentiate it with respect to z, and then add these different derivatives, partial derivatives. But remember, write with f of x dx, with f of y dy, with f of z dz. Then this is the differential. But here your function is two variables or three variables or four variables. So we use this term total differential. We add all these differences and we get the total differences of the given function. Concept will be clear from this example. What does this total differential mean? It's a simple concept. Find total differential of the function. W is equal to f of xy. It is clear from here that w is a function in two variables, xy, or you can say f is a function in two variables, x and y, defined as e power x square plus y square tangent 2x. Your function is in two variables. First, differentiate this f with respect to x. Partially, you get, you see, in partial differentiation, if we are differentiating the function with respect to x, we keep all other variables as constant. Here you have two variables, x and y. We are differentiating f with respect to x. So we have to keep y as constant. And when we differentiate f with respect to y, we keep x as constant. So f of x, fx is equal to, that is del f or del x is equal to, first differentiate this exponent. Here you have x square plus y square, keeping y as constant. Dx square over dx equal to 2x. It will be the coefficient of x bar, and then this since this y is a constant, which is 0, so you get derivative of x square plus y square with respect to x is 2x while keeping y as constant, and then write this e power x square plus y square, and this tangent 2x. Now differentiate this tangent 2x by using product rule. You see the given function, which is a function in two variables defined as e power x square plus y square tangent 2x. So this right hand side is the product of two functions, x and y. So by product rule, if you remember, derivative of u plus v is equal to derivative of the function, first function into second function, plus derivative of the second function into first function. So here you see your first function is on the right hand side, e power x square plus y square, which is 2x e power x square plus y square. This is your second function, plus know this function and derivative of the second function, which is tangent 2x. Derivative of tangent 2x is equal to 2 secant square 2x. Differentiate this 2x first, which is with respect to x, which is equal to 2, and then this tangent square, which is equal to secant square, and then differentiate f with respect to y. So first differentiate this exponent with respect to y, which is equal to 2y, and this e power x square plus y square, and this second function, this keep this as constant because it's a function in x. And in partial differentiation, when we differentiate with respect to one variable, we keep the other as constant. Here this tangent 2x will remain as the same. Now add this fx plus fy, but write dx with fx plus write dy with fy. You get the total differential, that is differential of w or differential of f is the sum of the two differentials. First differential is this, plus second differential is this. So the addition of these two differentials give you the total differential. So this is the total differential df is equal to this term into dx plus this term, this is your fy into dy. So by definition, this is the total differential of the function f in two variables, x and y. It's a simple concept. So there is an exercise, find total differential of the function. Here your function is fx, f in two variable, x and y, which is defined as x square plus y square. So first differentiate this function with respect to x, and then with y, you get the total differential df as, when you differentiate this with respect to x, you get 2x, y square is constant, 1 is constant, derivative of these two terms is 0 by sum rule, and then differential of the function with respect to y gives you 2y, because x square is constant plus y is constant and their derivative is 0. Adding these two, you get df, that is total derivative differential. Here you have this df. This df represent differential. And when it is written as df divided by dx, then it is derivative of f. अब ये differential है आपका, this notation, this represent differential of f. And when here it is df or dx, then it is derivative of f. So the differential of f is equal to x 2 times x into dx plus 2y into dy. This is written, this is 2x, not x, it is 2x. Similarly, you can check this example 2, example 3, example 4, and then this example 5 and 6. So these are simple examples of total differentials. Solutions are there. Please check it yourself. Now we move to another topic. It's about vector and scalar fields. Vector and scalars. Vector field and scalar field. These are two different concepts. Vector is a quantity which has magnitude and direction. Or you are considering vector in algebra, the elements of a linear space or vector space are called vector, and scalars. In algebra, scalars are numbers, any number, whether it is complex or real. But here we are discussing scalar field and vector field. What is scalar field? Scalar field in mathematics and physics, a scalar field associates a scalar value to every point in a space. If you are considering scalar field in a space, means in three-dimensional space, then every point will be a scalar. Or in other words, a scalar field is a map F from n-dimensional Euclidean space R to the set of real numbers which assigns each x in the space Rn, n-dimensional space, any real value because the image of any element in Rn under F will be a real number. So by definition, each element in the space will have some real value. So this F from Rn is an n-dimensional Euclidean space, you know this. So for any element in this Rn, it will be a vector, no doubt, but its image under this F will be a real number. So this is the definition of scalar field. Now we come to the definition of vector field. We are more interested in vector field. By definition, a vector field is defined by a function which associates a vector with each point in a domain of the function. Scalar field में any element in the space was associated with real number, and for vector field any vector is in the space is associated with any other point in the domain space of the function. So a vector field is defined by a function which associates a vector with each point in the domain of the function. जरा इसको गौर से देखें. What does this sentence says? A vector field is defined by a function. Vector field क्या होता है? It's a function which associates a vector with each point in a domain of the function. Function में जो भी एलिमेंट होगा उसका इमेज अंडर एफ विल बी ए वेक्टर, और स्केलर फील्ड में जो भी पॉइंट होगा उसका इमेज अंडर एफ विल बी ए स्केलर. दिस व्हाट इज द डिफरेंस बिटवीन वेक्टर फील्ड एंड स्केलर फील्ड. और इन अदर वर्ड्स, a vector field is a map from Rn to another to Rn that assigns each x a vector which we denote by f, capital F, x. This is a vector. So vector field gives you a vector. Scalar field gives you a scalar. To explain this more, a vector field in 2 or 3 dimensional space is a function, as we said, denoted by capital F, that assigns to each point x, y, if it is in 2 space, or if it is in 3 space, then the point will be x, y, z of 2 or 3 dimensional respectively, is given by, how do we define vector field? Which is denoted by f, this arrow, x, y, or f, ये ऊपर arrow लगा है, this represent vector, this f, x is a vector, and this f, x, y, z is also a vector. So note that the notation for vector field is this capital F, upper arrow, and this x, y, if it is in 2 dimensional, this f, arrow, x, y, z is a vector field in 3 dimensional space. The standard notation for the function f for the vector field क्या होता है? It's a function associate a vector with each point in the domain, and it is denoted by capital F, and this arrow is defined as fxy is equal to m into this point xy plus n, and this I vector plus n xy j vector. This is the notation for vector field in two-dimensional space, or in three-dimensional space it is defined as m this point I vector plus n xyz j vector plus pxyz k vector. अब ये I J K कौन से vectors है? These are unit vectors. But also remember that here this M, N, and this P are themselves scalar functions in two variables or in three variables. So vector field in two variables is defined as M xy I vector plus N xyj xy j vector, but here these m and n are both functions in two variables. Hello. Walaikum salam. او زیرو خبره که او سو خبره که از ته لږه داسې وکړه ته راغلی که لا راغلی نه یې ښه دا واټساپ نمبر خو دغه دی دا وخت زه په یونیورسټي کې کلاس کې که نه ښه په دغه نمبر یې راسینډ کړه که نه دغه واټساپ نمبر هم دی ٹھیک شو نه 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 هغه د واده دی ولیمه ده اوکې اوکې Okay, sorry for the interruption. So in this way we define a vector field. Vector field is, if it is in two-dimensional, by definition, m time this function in two variables, I vector plus n function in two variable, this j vector. If it is in three-dimensional, m I plus nj plus pk, where ij and k are unit vectors. So this is the definition of scalar vector fields in two-dimensional and three-dimensional. Now using this concept of vector field, we define the divergence and curl. You might be familiar with the definition of this divergence and curl while reading in MSc BS. Concept of divergence and curl lies in vector analysis. Anyway, first we define divergence of a vector field. Divergence of a vector field is a scalar quantity, as you will see by definition. First, consider a scalar field f in 2 dimensions, which will be equal to mi vector plus nj vector by definition. At the point xy means that it is in 2 space. The divergence, also called flux density of this vector field, is defined as divf. This is the notation for divergence. Divf, or this nebula, this inverted delta dot f is equal to partial derivative of m with respect to x plus partial derivative of n with respect to y. The divergence of a given scalar field f is defined in this way. If your scalar field is in 3 space or 3-dimensional space, it will be defined as, notation is the same, div f, or del inverted this nebula, which is, this is the notation of nebula, dot f, it is equal to partial derivative of m with respect to x plus partial derivative of n with respect to y plus partial derivative of p with respect to z. Note that the symbol divf is read as divergence of f, and this del f is read as del dot f. Mind this dot, del dot f. So it's clear from the notation that divergence of scalar vector field is a scalar quantity. Because you can't see any vectors here on the right. So by definition, divergence of function vector field f in 2-dimensional is defined like this: del f m over del x plus del n over del y, and divergence of scalar field in 3 variable is defined as del m over del x plus del n over del y plus del n over del p over dz. Now here this is a remark. From definition, it is clear that the divergence of a vector field f is a scalar quantity. Remember this. Sometimes examiner can ask you, tell us whether divergence is a scalar quantity or vector quantity. So clearly, by definition, it is a scalar quantity. Example of a divergence, simple concept. Find the divergence of the scalar field f equal to 2x zi vector plus minus x y j vector minus k vector. This is given vector field, and you have to find its divergence. Note that, or compare this with the general definition of vector field in 3 space. You see that your m is 2xz because the coefficient of I vector is denoted by m, coefficient of j vector is denoted by n, coefficient of k vector is denoted by p. So here m is 2xz, n is minus xy, p is minus z. Now what you have to do? Simply differentiate m with respect to x, n with respect to y, and z with respect p with respect to z. You get del m or del x equal to 2z, del n or del y is equal to minus x, del p over del z is minus 1. Putting the values in the definition of divergence, so divf or del dot f is by definition is equal to del m or del x plus del n or del y plus del p or del z. Putting the values, you get divergence of f as 2z minus xy minus z. So you see the expression on the right hand side is a scalar quantity, and this confirms that divergence of vector field is a scalar quantity. Another example, find the divergence of the vector field f, which is defined as x square minus y I vector plus xy minus y square j vector. So you see here this function is in two space because you have I vector and j vector. Solution, clearly m is x square minus y, n is equal to xy minus y square. Differentiate m with respect to x, you get 2x. Differentiate this scalar function n with respect to y, you get x minus 2y. And then putting the values in the formula for divergence of vector field, you have this 3x minus 2y, which is the divergence of this given scalar field. Right, this was a bit about divergence of a vector field. Here is one simple exercise. You are given divergence. For example, in the first exercise, scalar field is minus y I vector plus x j vector over x square plus y square 1 over 2, and this particular vector field is called spin field. To this vector field is given this name spin field. If it comes in the paper, to find the divergence of the spin field, so you have write this expression for the vector field f. Spin field is a vector field which is equal to minus y I vector plus x j vector divided by x square plus y square power 1 over 2. If your vector field is in this form, then this particular form of vector field is called spin field. You can see the solution. You get divergence of f as x divided by xy divided by x square plus y square whole power 3 by 3 over 2 minus xy divided by x square plus y square power 3 over 2 equal to 0, because there will be sorry, and these two cancels, you get the answer as 0, and there is no third term because your field is in two space. This second example, your scalar vector field is x iota vector plus y, and this I vector plus y vector into J. There is some problem here in the writing. Your vector field F is equal to xi vector plus yj vector. This arrow is over J, not on Y. F, your vector field F is equal to xi vector plus yj vector. This arrow is over J. Note this, make this correction. If your vector field is in this form, then this special form of this vector field is called radial field. If somebody asks you find the divergence of a radial field, so you have to write this expression for the vector field. Solution is there. Please check it yourself. Move to another exercise. Vector field is given, and this special form of the vector field is called gravitational field. This is the definition of gravitational field in physics, right? You have to find its divergence. You see your this vector field is in 3 space because you have I vector, J vector, and K vector. So your answer will be divergence of x equal to del m or del x plus del n over del y plus del p over del z. Find the value of del m, del n, and del p. Find the solution yourself. It's an exercise for you. And this fourth, if your vector field is in this form, we have denoted it by v equal to x square minus r square k vector. And this particular form of the vector field is called velocity field. So find the divergence of this vector field as well. These two problems are left as an exercise. Try this at home. And this is the end of the midterm course. So the paper will contain question from lecture 1 till the end of lecture 8. So don't leave any exercise or any question without attempt. Try all the questions. Any question can come from the material up to till date. So any question about this vector field or total differential? Hello, Haknawaz, Rahmat, Imran, any question?
No, sir. Clear है,
No,
sir.
sir. Okay, आप ऐसे कर लेना. आज तक जितना भी हमने पढ़ा है ना, पेपर इसी में से आएगा. डोंट वरी, कोई ऐसा अनसीन प्रॉब्लम नहीं होगा पेपर में. लेकिन कोशिश कर लें यहाँ तक जो कुछ पढ़ा है इसको तैयार कर लें. ठीक है?
ओके सर, ओके सर.
राइट. अब वो मजा तो नहीं है जो क्लास में होता है. बहरहाल कुछ गुजारा हुआ होगा, नोट्स अपलोड हुए, इसको देख लें. कोशिश तो मैंने पूरी की कि एक्सप्लेन कर दूं, लेकिन जैसे क्लास में माहौल होता है वो तो बन नहीं सकता. एनीवे, विश यू ऑल द बेस्ट. असाइनमेंट भी 10th जनवरी तक आपने अपलोड करना है, एडवांस कैलकुलस का भी और फंक्शनल एनालिसिस का भी.
सर.
हाँ
सर जी, पेपर फिजिकली होंगे या ऑनलाइन पेपर होंगे सर?
ये अब इनकी मर्जी. इनके साथ बात कर लेना जो आपका कोऑर्डिनेटर है आमिर ना, उनसे
अच्छा
पूछ लें ऑनलाइन एग्जाम होगा या यूनिवर्सिटी में आना पड़ेगा।
ठीक है सर, ठीक है, थैंक
ये
यू सर।
कभी कर लेते हैं ना, कुछ को मतलब ये जो आ सकते हैं यूनिवर्सिटी, उनके लिए यूनिवर्सिटी में रख लेते हैं। पिछली दफा इन्होंने
अच्छा
ऐसा किया था ना, जो
अच्छा
यूनिवर्सिटी में आना
सर।
चाह रहे थे उनके लिए यूनिवर्सिटी में अरेंजमेंट की थी, और जो ऑनलाइन देना चाह रहे थे उनको इजाज़त दी
अच्छा,
कि आप अपलोड कर लें ऑनलाइन।
ठीक है सर, थैंक यू।
ओके, ओके, बाय बाय।
थैंक यू सर।
राइट।